Precipitation forms in the clouds when water vapor condenses into bigger and bigger droplets of water. When the drops are heavy enough, they fall to the earth. If a cloud is colder, like it would be at higher altitudes, the water droplets may freeze to form ice. The first form of precipitation I'm going to talk about is rain. Rain is moisture condensed from the atmosphere that falls visibly in separate drops. Next, we have snow. Snow is precipitation in the form of ice crystals, mainly of intricately branched, hexagonal form and often agglomerated into snowflakes, formed directly from the freezing of the water vapor in the air. Next, we have sleet. Sleet is a type of precipitation distinct from snow, hail, rain, and freezing rain. It forms under certain weather conditions when a temperature inversion causes snow to melt and then refreeze. Last, we have hail. Hail is formed when drops of water freeze together in the cold upper regions of thunderstorm clouds. These chunks of ice are called hailstones. Most hailstones measure between 5 millimeters and 15 centimeters in diameter and can be round or jagged. In meteorology, an air mass is a volume of air defined by its temperature and water vapor content. Air masses cover many hundreds or thousands of miles and adapt to the characteristics of the surface below them. Meteorologists identify air masses according to where they form over the Earth. There are 4 categories of air masses: Arctic, tropical, polar, and equatorial. Arctic air masses form in the Arctic region and are very cold. Tropical air masses form in low latitude areas and are moderately warm. Polar air masses take shape in high latitude regions and are cold, and equatorial air masses developed near the equator and are warm. Air masses are also identified based on whether they form over land or water. Maritime air masses form over water and are humid, and continental air masses form over land and are dry. Oklahoma provides a fertile breeding ground for tornadoes because of the clash between the warm, moist air from the Gulf and cold air from the Rockies in Canada. It's a large mixture of temperature and temperature change within a small distance. Air also flows vertically, which we call lift, but air doesn't lift all by itself. It needs help. There are 4 main processes that lift air, known as lifting mechanisms, but I will only be going over 2. When air does flow upward, we get some pretty interesting weather processes, like cloud formation, precipitation, thunderstorms, tornadoes, and hurricanes. The first way that air is lifted is through orographic lifting. This is when air is lifted over an obstacle, like a mountain. As air moves across an area, it sometimes runs into obstacles, like mountains, and of course, it has nowhere to go but up. As the air is forced up the side of the mountain, it cools and condenses, which means it gets more compact. Most of the moisture in the air gets forced out as the air condenses, which forms a cloud over the side of the mountain. And this is known as the windward side. It's called the windward side because this is the side of the mountain the wind first encounters. The cloud is full of moisture, so it's also pretty rainy on the windward side as well. The second way that air lifts is through convergence, which is when air converges in the center of a low pressure area. As air flows horizontally and meets along the surface of Earth, it's forced upwards since that's the only place it can go. Convergence is responsible for some well-known weather events, like hurricanes and cyclones. In fact, these storms only survive if wet air continues to converge in the center. If it stops, they die out. Thank you, and this concludes my presentation.